I wanted to say a little bit about why I'm so passionate about making LLMs work in production, maybe more broadly, making AI work in production. It's the thing that I've done throughout my career. I originally was an AI researcher over 20 years ago, and the thing that I saw back in 2006 was that the thing holding back AI at the time, arguably still today, is the availability of high-quality training data sets for specific applications. And so back in 2006, I started a company called Crowdflower that was once a crowdsourcing data labeling platform and then became a non-crowdsourcing data labeling platform. And so changed the name to Figure 8, but we helped thousands of companies collect data labels to do all kinds of different AI projects. After the company sold, I was really, really excited about the emergence of deep learning, and I was feeling actually a little bit sad that I had been running a company for 12 years, writing very little code, had kind of fallen behind the times, and was watching all these applications that seemed like a dream start to really work. I don't know if you remember the Nature paper where ImageNet came out, and actually training on ImageNet also allowed for cancer detection and skin cancer. And I just thought that was so cool to see. First of all, being able to label images with an AI was amazing not that long ago. But then to be able to take labeling images in one domain and apply it to another domain just blew my mind. And I really wanted to get back into it. I actually didn't really want to start another company. I was happy. I started interning. I had an unpaid internship at OpenAI when there were about 30 people. And I said, hey, just let me do whatever work you want. I just kind of want to start moving my fingers again and writing code. And I got really obsessed with actually deploying deep learning models to cheap hardware. I also thought it was super exciting 5-6 years ago that you could take a large model and put it on a Raspberry Pi and put it on a little car. And the accessibility of deep learning at that time, that you could build models, deploy them on $100 hardware, just blew my mind. So I spent a lot of time kind of tinkering and on projects. And out of those projects emerged a company called Weights and Biases that at least one of you in the audience uses. I'm curious, how many Weights and Biases users do we have? Is this a Weights and Biases audience? Not at all. Awesome. So you should use Weights and Biases. So Weights and Biases is an AI developer platform. And I started it because I wanted to make tools for ML practitioners to help ML practitioners specifically get models from idea stage to deployed and working in production. And so, we've helped model builders everywhere from drug discovery to OpenAI and the kind of the Meta and the kind of big LLMs that you might have heard of, to John Deere helping them make tractors that do farming better. And these days we actually help a lot of companies build and deploy LLMs into production. The problem that I set out to solve when I started Weights and Biases was this, and what I observed is there's a software workflow that we've been kind of tweaking for the past 50, 60 years to kind of get software reliably working in production. And that workflow, I think, is well understood, and there's actually very successful companies that will help you at every step of the workflow. And this is 6 years ago, but there's also a pretty well understood ML workflow at the time. Andrej Karpathy called it software 2.0. And you could argue about exactly what the boxes are in that workflow, but one thing was for sure at that time, which is that the boxes were filled with really, really ad hoc solutions. There wasn't a really great CI/CD tool for ML systems. And in fact, people would not use typically a Circle CI for their ML systems for a variety of reasons. And so I wanted to help fix this. And I think when I even took a further step back of why aren't there tools at that time, I think that the workflow of an ML practitioner, and I would argue a lot of data applications, is really different than a software engineer in the sense that ML is fundamentally an experimental workflow. So developing software I find super satisfying. It's super fun. You add features, you debug the features, and then you get a new set of functionality, and then you add a new set of functionality, and then you start complaining about tech debt, and the speed slows down. But I think especially in the beginning, it's a very, very fun process. Doing machine learning is a much tougher process. It's much more of an exploration, right? You don't necessarily know where you're going. Most of what you're doing is actually looking at the results of the model and then thinking up new ideas of things to try. And I think that that experimental workflow leads to really different set of requirements. And that's why things like Jupyter Notebooks and Streamlets are so powerful in the ML world, but they really don't cross over very often into the software developer world. I think Jupyter Notebooks still sometimes freak out software developers, even though they're completely ubiquitous in the ML domain. And at the time, I'm kind of going back into history a little bit, but my doing an ML tools startup 6 years ago actually was controversial. And to prove it to you, like the day I started the company, there was an article that came out in Medium, your deep learning tools for enterprises startup will fail, written by a Databricks product manager. So maybe not totally unbiased there, but actually had a pretty good thesis about why it's a bad idea to start an ML tools company. And then I'm curious, how many people in this audience are entrepreneurs? I was feeling like kind of a lot, just kind of walking around. So I put in a couple slides for you entrepreneurs. I really wanted to show this. So we launched our product, and we did not launch our product on day one. It probably took us too long, but as a second-time entrepreneur, I am obsessed about getting something out to market quickly. But we got it out, and this is a graph of our weekly active users for the first year. So you can see, kind of week one, there's maybe 2 weekly active users. That might be me and my co-founder. I don't know why my third co-founder isn't using the product. As you can see, it sits at about 3, for the first couple months. And then by the end of the first year, we were really proud to have 29 weekly active users. Right? This is with Weights and Biases, the product. And I wanted to talk a little bit about what worked for us, and this is especially to the entrepreneurs in the audience. This is like my best entrepreneurial advice. I think the best thing that we did was we collaborated with the users that loved us. We worked with our heaviest users. So this is a picture of Carrie, our first PM, who joined us as our kind of fourth person. And she's working with Peter Wellander at OpenAI. Now he's a VP of product at OpenAI. But at the time, OpenAI was a 30-person company. He was an individual contributor. They were a nonprofit. It seemed like a weird customer. But what we did know is they were one of the 3 companies using us. He was one of the 20 weekly active users that we had. So we went over to his office a whole bunch of times, and he pulled up Weights and Biases on his screen, and he told us what plots he wanted, and we just kept making him the plots that he wanted. We also really listened to customer feedback. I got really obsessed with NPS. I think it gets a bad name now. There's people inside Weights and Biases that don't like it, but I love the score. I love just asking somebody, would you recommend the product? And then when people say I wouldn't recommend the product to a friend, fixing the problem that makes it so they wouldn't recommend the product. We got our setup really simple, actually because I felt bad. I kept hearing excuses from my friends, my good friends, that wouldn't use Weights and Biases. They'd be, training models, putting them into production. I'd be like, well, why don't you use Weights and Biases? We're not even charging you for it yet. Like, what's the problem? And they would say, I just didn't have time to instrument Weights and Biases. And I'd be like, man, it's 10 lines of code to instrument it. It'll take you an hour. And we kind of realized even that's too much, and so we kept just reducing it to kind of take away excuses of our friends who weren't using it. And I actually think that, honestly, this might have been the best thing that we did, was getting it down to a 2-line, 60-second integration. I think to make it that simple and actually be useful and powerful is a really hard undertaking, and we should have pushed on this even harder earlier. The other thing that we did was we integrated with everything. Actually, Lavania's here in the audience. She was kind of the first person who came in as an ML engineer and got us integrated into every code base we could find. And we kind of realized these integrations are actually part of the product from our customer's perspective. So the fact that you could be using PyTorch and then turn on Weights and Biases in a nice way with one line, people just loved it. And it also met our customers at the place they were at. So Weights and Biases was appearing where they were training their models. They didn't have to go find us. And it was really hard. We had to be really nice to these weird, open source repositories that all had their own opinions and would complain about our PRs. But we really worked to kind of make them happy and do our own integrations into these repos. And so we kept building on that. And you can see actually the repo instrumentations kind of just going up and up and up over the lifetime of the company. And then the next thing that happened was everybody wanted collaboration, because I think when you're in experimental workflow, the real product that you get when you're doing experiments is the insights that you get. So it's like the actual artifacts that you're generating that you care about in an experimental workflow is what you learned, and you want to be able to share that. And so this actually worked really well for us, right? To make it really easy to kind of keep track of what you did and send it to a colleague. And of course, this helped us with our user numbers, but I really think we invested much more time in this than any of our peers, and this still kind of stands out as what our users tell us they like about us. And then the kind of the other part of that is making reproducibility really easy. So I think, again, in experimental workflow, you're changing things all the time. So reproducing something, even that you did a week ago or a month ago, it's important and really hard. And so we put a lot of care into that. And then finally, the biggest surprise maybe was, and this is maybe the biggest undertaking for us these days, is working well with enterprise infrastructure, right? There's just so much legacy stuff out there. There's so many different kinds of security concerns that folks have. And I actually get excited about this, even though it's not, the kind of feature launches you do around this are sort of like less easy to like tell your friends about. I feel like as AI becomes more and more mainstream and more enterprises adopt it, you get AI in more interesting and important applications. So that's really what I guess we've been doing for the last 6 years. And I mean, I don't know if this is kind of bragging, but also I hope this gives somebody in the audience some hope. So that number actually did take off. And there wasn't kind of one moment, I could tell you like a simple story that was like one thing we did, but it definitely wasn't. It just was like slow and steady exponential growth that compounded, and that 26 turned into over 50,000 these days. We also work with customers across almost every industry. And this is people making fun games, making organic farming easier, making better medicine, making customer support less frustrating, kind of all the things that people in the audience yelled out. I think the coolest thing about working in AI right now is how many industries use it. Really, all industries use it. Like we work with a huge fraction of the Fortune 500, and the fraction that's not working with us, they really should be working with us. It's not like they're doing something where we're not relevant. But I think one of the things that we're maybe most proud of is basically all the foundation model builders used us. So OpenAI, now you talk about Mistral, and there's always a new foundation model, and that's really been kind of our bread and butter. And I love what they're doing, right? Because we started out building tools for ML practitioners, and we defined ML practitioner as someone making AI work in the real world. But to be an ML practitioner, you really did have to have a fair amount of specialized knowledge in the past. And so our user persona in the past was a much more kind of specialized researcher type of person. And I think these foundation models have made it really possible that any software developer can become an ML practitioner by that definition, which is just so cool. And it's radically changed our user persona, right? We now see more software developers using our product than ML people. And we've actually kind of split the persona into really 3 different sub-personas, but to us, these are kind of wildly different types of people. There's the LLM creator, which is like, the researcher at OpenAI that's, kind of working on GPT-5, right? And they really, really care about scale. They're just hardcore in every way, right? And then there's the LLM fine-tuner, which is, maybe it's like more like me, right? Someone, kind of taking upstream models and trying to like tweak them to do something useful. Maybe they have an ML background, but even these days, you wouldn't necessarily need to have that. And then finally, there's the LLM user, which is like the software engineer that's like hooking up, APIs and trying to get, LLM out of the box as an API to work for some use case in the real world, which I think is like by far the biggest growth area for us. And so these people are very different. They operate at wildly different scales, but I really think they all have a similar workflow if you squint, which is that they're trying things and then they're looking at experimental results and then trying more things, right? As opposed to that software developer workflow where you're kind of like iterating by building things, right? They have to have a much tighter experimental cycle, whether or not whether their evaluation set is like all text in the world or like, 10 hand-picked ultra-specific examples. And so, I say, people building models or using LLMs, it's really the same kind of person, and we want to make tools for them. And so, in that journey, one of the things that I realized was actually I understand the ML workflow super well. It's something that I had really done. And when my son was born, I went on paternity leave, and then we actually have a very generous paternity leave policy at Weights and Biases. He's kind of the second kid, so he'll be fine. It's like a lot less stressful than the first kid. And so I really wanted to see, okay, what is it really like to be, someone that just like uses LLMs for a use case? And so I kind of got inspired for a use case by my daughter, who actually loves our Alexa in kind of a crazy way. I feel like she actually has a relationship with our Alexa. And so one day she asked the Alexa, play my favorite song. And Alexa actually doesn't know what her favorite song is, but it is like insane to not know what her favorite song is. Her favorite song is Baby Shark. And it's like, she asked the Alexa to play it like 100 times a day, right? So when Alexa didn't know what her favorite song was, I understand Alexa has privacy policies that don't let them do this, but her user experience of that was tears. Like literally like tears, like, oh, my friend the Alexa doesn't get me, isn't like paying attention to me. And so I thought, man, it'd be so fun to take LLMs and like build, an open source thing where the data wouldn't have to go out to the internet, and it could just kind of do, interesting things that my daughter, wants it to do. So I did a little research on what's out there. There's a cool project called Mycroft, but it's kind of out of date and doesn't use LLMs. So this would make you sort of an open source Alexa using kind of older NLP methods. But I thought, actually a friend of mine and a neighbor of mine released this incredibly cool thing, which is a rock pie where he got Llama 2 and Whisper running on it. So it's a $200 device where you can run a Llama and a Whisper model. So, okay, this is the perfect platform for me to use. It's kind of already set up to run at least like 7 billion small model, 7 billion parameter model. And so I built this. I guess if we have a video in here, I can show you kind of how it works with my weird little UI that I built. The video doesn't load, sorry. Anyway, so what you do is you ask it, like, basically play my favorite song, and it will, indeed play your favorite song. And the way that it works is with a library of skills, right? So you can actually program like little skills that might be like, okay, if somebody's asking for the weather, go out to Weather API and return the weather. If you're asking for like a math problem, just do the math problem and return the math problem. So, it's an extensible set of skills. The challenge here is understanding, from some spoken audio to what the person is asking for, and then it has to be into like a code-like language where the skill can actually execute. So here, I might ask, what's the weather in Boston? It says, okay, in kind of like Python-looking language, weather, and that says, okay, call the weather skill and say that the location equals Boston, right? So, once you have that translation into weather location equals Boston, a pretty simple task, right? You can actually get Copilot to write you these skills super easily. So I made an open source stack. I used Whisper. Anybody use Whisper in the audience? I love Whisper. It's funny, I used to actually work on some speech-to-text stuff, and it's like incredible to me that OpenAI just open sourced as kind of like a fun side project, such a fantastic speech-to-text model. And then I used Llama at the time. This is Llama 2, and then I tried some other things. Also, Llama CPP, I don't know if anyone uses this. This is like a feat of engineering to get these models to run efficiently everywhere. There are all alternatives out there, but I love that I can run on my MacBook, run on my RockPi, kind of run these models everywhere I want to. I'm so sorry these videos don't load, but basically, this works really well, guys. Don't worry, it works. This is a fantastic product. But I will say, one thing that I learned as like a very amateur engineer here on a kind of open source Alexa is like latency matters a lot. If you get over like 300, 400 milliseconds, it becomes incredibly annoying, and I don't want my daughter to be annoyed by the thing that I'm building for her. So you're really making like a lot of trade-offs to try to get that latency down. Because there's actually two steps, right? One has to do this transcription, then it has to turn the transcription into through the LLM. So I kind of wondered how well this task would work. And it turns out, like, if you take the default prompt and you just sort of say, hey, do this translation for me, it doesn't work at all. It's literally 0% of the time off the bat. And I kind of played around with making the prompt better, and I tried to be more explicit. I read some blogs on like good prompt engineering and tried to kind of lay out what I'm trying to do, and basically still got 0%. Although here I'm measuring accuracy by did you actually return like weather location equals Boston, and in this case it was I could tell it was kind of getting closer. Like it's saying it actually kind of got weather location equals Boston nested in a bunch of gibberish. So still at 0%, but kind of felt like it was getting closer. And then I switched to Llama 2 chat. I mean, this is, again, there's lots of models out there. There's better ones now. This was 6 months ago. But I kind of thought that it might work better. And it had been trained on a conversation, so it kind of fit my model a little bit better. And actually, it got 11% accuracy. So I was starting to get excited. At least it got some of these, started to get like some of these right. There's a bunch of different ways you can kind of get rid of the chatty output. You can sort of like, you can be more restrictive in the way that you can actually even put kind of regular expressions that you insist that the model returns. But I kind of wondered, actually, because it's saying user query colon, and it kind of kept saying function call colon. I thought, it really, really wants to tell me function call colon. These are the insights that you came to this conference for, I'm sure. So I was like, what if I just add function call colon? Maybe that will help it. And actually the feedback from the model caused the accuracy to jump up to 75%. So this is not exactly using my computer science degree, but it did. It was kind of fun how much it improved things. Just again to show you the sort of like nature of this process, adding examples to the prompt really seemed like it would improve it, but they kept actually making this model work in this case, which shows you that best practices don't always work super well. But then actually I thought, Mistral had actually just come out, and I thought, I wonder if I try Mistral's model, and it has a very similar API, very similar sized model, similar performance characteristics, and this is super cool. It caused, for free, basically the accuracy to jump up to 79%. So now it's kind of starting to get in the range of like, wow, this could be like a working product, but I will tell you, if you deploy a 79% accurate model to your kid, and there's also some noise from the speech to text, kid is still definitely not impressed. It still feels like a bad user experience, still pretty annoying. So I thought, okay, let's try fine-tuning. And a couple years ago, fine-tuning was kind of this like research topic. It seemed like really daunting, but actually LoRa and QLoRa has made it totally accessible. So I was actually able to use QLoRa. I was kind of amazed with the 7 billion parameter model. I was able to fine-tune it in a GPU in my basement that like plugs into normal power supply in about 30 minutes on my example. So I think this, and it wasn't super hard. I was copying a lot of code that I didn't totally understand, but it worked great. But the challenge here, and this is something I'm used to from my data labeling days, you do need a data set to fine tune. And so, I started by actually creating some examples. I started just like putting in, things I thought my daughter, might ask the system to do, and what I wanted it to do. Obviously, this is kind of a slow process, but then I thought, well, I could just ask ChatGPT to give me more examples. A lot of my friends do that. It actually worked fantastically well. Like once I had a couple examples of what I was looking for, 90% of examples were high quality. It even put them in a format that was like ready to go for my fine-tuning system. And actually, after fine-tuning on about 500 examples, the accuracy went up to 98%. So this was like such a satisfying project, right? It went from 0% accuracy, and not sure how well it would go, all the way to 98% accuracy on a 7 billion parameter Mistral model that I could deploy into a $200 device. So, lots of fun. And actually, I discovered it works for other languages. I didn't even intend for it to do it, but these models, both the Whisper model and the LLM model, were trained on multiple languages and seem to work well. The one other language I speak is Japanese, ironically, which seems like kind of a hard choice. And that one seemed to work very well for the kind of simple questions that you might want to ask. And so you can find this project at GitHub/Lukas/Otto if you want to play with it or try it. And I think the lessons learned for me was that prompt engineering really matters, but also fine-tuning really matters, right? So these things we talk about, actually, if I'd only done one of the two, I'm pretty sure it would not have gotten to a level of accuracy where I could deploy it. So for this specific example at this moment in time, definitely need fine-tuning and definitely need a lot of thought around the prompt engineering. And I should say, I'm omitting about 100 things I tried that didn't work, right? So you get these funny things that do work, but mostly they don't work. But we did actually, I made a report for my team that also I just published, where you can actually see all the things that we tried that didn't work, which you'd want to do in sort of in a business context. I also didn't want to just show you an example that feels like such a toy example. We also internally, at the same time, built a thing we call WandBot, which was designed to automate our customer service. I know there's a lot of companies out there that will do this for you, and I think they do it really well. We really want to do this, one, because we wanted the output, but we also internally wanted to experience what it was like to run a production LLM system on something that we really cared about. And so, the task here is we actually do this all the time in our Slack channel, in our Discord channel for our free users, where somebody puts in a question and you give an answer. Actually, GPT-4 because I think there's so much open source done on weights and biases, it's surprisingly good at giving answers on the topic of weights and biases, but it also hallucinates a lot, which scares me. And it often is operating off of old documentation. So it's kind of hard when we make an API change to get the world to know about the API change because it takes a while for GPT to learn about it. So, we have a typical RAG pipeline. I'm sure there have been a lot of different talks on a RAG pipeline. This was, this is kind of ours, I think, fairly vanilla, right? We basically, in the upper left, the user query comes in. User query might say, how can I log my inputs and outputs from OpenAI? This is how it looks in Discord. We then have a basic template where we paste that query into a template, saying what we want. We're begging GPT to not make up an answer. Kind of anticipating that would be sort of bad behavior. And we kind of continued to improve the prompt templates, looking at the output. Obviously, the prompt gets longer and longer and more intricate. We also built a RAG pipeline on a Chroma DB vector store, and it works really great. For those of you not familiar, actually, how many people are familiar with the RAG pipeline? Is this how deep in our consciousness is RAG at this point? It's hard to tell. So my high-level take of RAG is, you basically you take your documents and you encode them into vectors that encode the meaning somehow in numbers, and you take your query and you encode that into numbers, and then you sort of look for a set of numbers close to your query. And the impact of that is that you can do really high-quality semantic search in a lot of cases. So we filled a vector database with our docs, and then before we produce the output to the user, we look for relevant docs in our documentation. So we put the output from the RAG into our prompt, and then we feed that full prompt into GPT-4. And then it responds to the user. And so, sometimes this works awesome. It's absolutely magical, and you can go to our Discord server and get this, but not all the time, right? So we collected user feedback on how much they liked it and didn't like it. This is actually harder to evaluate than the OttoBot that I showed you, right? Because it's not one specific answer you're looking for. You need to actually have an expert look at this and say if it's good or bad. So we tried both having humans evaluate it, which is slow and expensive. We tried having users evaluate it, which is cheap but very unreliable. And we also tried having the LLM evaluate itself. We also tried to get representative examples to evaluate on, especially when humans are involved. So, if we have a bug, we'll get tons of questions just about that bug, right? And so, if you actually look at our real-life data set of questions users are asking, some topics are massively overrepresented. And so we actually tried to do clustering on the vectors, the semantic vectors that came out of all the topics, and then tried to pick representative examples from each topic. So we get a wider spread of things to evaluate over. So that reduced our evaluation set down to 132, which is still pretty painful to have a human look at them and try to decide if they're right or wrong. Based on the expert evaluation, you can see our little interface that we built here for doing that expert evaluation. We had 70% accuracy. So actually, interestingly, humans gave this model a higher score than the model gave itself. So when the model decided to evaluate itself, it was in the 60s. Humans actually gave it a 70% accuracy. But this is a hard task, and it's actually a complicated task. So what does accuracy mean in a RAG pipeline, right? There's a relevancy component to it, right? You want to answer the question that the person actually asked, right? But you can also give a relevant answer that's totally wrong, right? So that's where faithfulness comes in. Almost the worst thing you could do is give an answer that sounds really right, feels really relevant to the question, but is completely misleading. You can also, answer with a true statement that has nothing to do with the question that the user was looking for. So it's actually really important to have a whole bunch of different evaluations, and we ran these evaluations across different models. Here even different GPT models, different versions of GPT gave us wildly different scores, and some were actually better with faithfulness, and some were better with relevancy. So you really have this product decision to make of, okay, what do you really want here? We ended up going with this GPT-4 1106 preview, and then we even started adding in kind of off-the-shelf metrics. So we realized we were kind of inventing our own standard metrics, but there's also libraries out there that will give you metrics. So the Raga score has a metrics which you could automatically plug in, and we could evaluate these models across kind of an expanding set of metrics. And again, we documented all this. Also, if you just want to see another real-world example at wandeme/wandbot, and we've kind of continued to iterate on this because it's something that our users really care about. You can actually go use this yourself on our Discord. I think the most interesting thing is the most success that we've had here at Wastes and Biases has been our enterprise-oriented customer support team using this model. So they definitely use it all the time, every day, and they seem to like it even more than our users say that they like it. So this is the feedback from our internal team, and I think they are using it more as a starting point for debugging issues than always given exactly the right answer that a user has. So when I was kind of previewing this talk with Roger, one of the conference organizers, he was sort of giving me the questions that he thought it would be good for me to answer. And actually, we talk to enterprises daily, and the questions are really similar. And it's kind of all about like, what should I be trying, right? Like, which foundation model should I use? Should I use fine tuning? Does that trade off against RAG? Is it complementary or what? What vector database should I use? Like, how much should I care about that? And I guess like, not only are these answers application dependent, like clearly application dependent, like these two stories that I've just told you actually have some different conclusions baked right into them, but I think they're very point in time dependent. Like I think when someone makes a strong statement about something like fine tuning, my thoughts on fine tuning would have been different a year ago. And so I think a year from now, they're likely to be pretty different again. So I think what I instead leave you with is I think the most important thing that our customers are most messing up and not spending enough time on is building an evaluation framework, right? No one spends enough time on this, or no one spends as much time as they would really benefit from it. I think even us internally kind of knowing this, we probably should have spent more time on the evaluation framework up front. I also think getting a lightweight prototype into production is so important because there's so many weird, unexpected product issues that come up when something's actually running in production. I think even with this wandbot, we spent too much time tweaking the accuracy before it was running in front of users, and we would have had better metrics up front if we had gotten something live. I think incorporating end user feedback into the process, again, super critical because you worry that you're over-optimizing for your metric. End user feedback is so application specific. It's hard to give really good best practice advice here, except that you definitely need a way to do this. And then finally, I think the speed of iteration is actually the most important performance metric for you, right? Like if it takes you 2 days to run your evaluation set every time, that is your bottleneck for sure, right? Like if it takes you a month to get something in production, to get feedback on it to do again, then that month is your bottleneck. So shortening that iteration cycle, I think is, if you're kind of overseeing a team, is the most important thing to focus on. And I think that actually ML practitioners kind of intuitively get this. And I think what's happening right now is kind of software developers are entering more of an experimental workflow and kind of needing to learn these sort of best practices that MLOps has long been doing. I wanted to zoom in just briefly on evaluation best practice because it is the most important component in my view. And I'll say, like, if I could leave you with this, I think this is the most important thing. First of all, you probably want multiple evaluation sets. Almost all of our users that we talk to end up with way more metrics than you would think from the beginning. Like even wandbot kind of starts with accuracy. I think now we have 10 metrics that we check it on. And also there's almost always kind of a quick and dirty data set that you can run in seconds that you can iterate on, and then something that takes like an hour, something that takes like a day. There ends up always being these sort of different sizes and scales of evaluation. I think the second thing is making sure your metrics correlate with user experience. They never correlate as much as you think. So again, I think accuracy probably doesn't really correlate as much with user experience as just not hallucinating for wandbot. But we just see this over and over. And then the final thing is actually do it. I mean, I don't want to call out our customers by name, but I have a podcast actually where I talk to people building out LLM applications, and several people on the podcast, I mean, CEOs of companies you would have heard of, say that we test our LLMs by vibes, right? which like really means like not testing. And I think I started to joke about testing by vibes, and then people are like, "Oh yeah, that's like that's right, that's what I'm doing." You know, and I really don't think that. I think that works great at first, and it's good that you're looking at the results. But the problem is you can't iterate, and then you keep asking me questions like, "Should I fine tune or not?" And it's like, actually, you shouldn't be asking me if you should fine tune or not. You should be trying fine tuning and seeing if it works for you or not, because it matters what you're doing. So I'll say one final thing is we have a new product out designed for experiment tracking for LLM users. We haven't started to promote it aggressively yet. It's probably at that sort of 20 weekly active users, but we'd love for you, if you're interested, to be design partners here. So if you go to wandb.me/weave, I'd love for you to try this new thing that we're working on. Here's some screenshots where you can sort of see it help you debug your LLM workflows. So for those of you that are thinking about putting LLMs into production, we'd love to hear your feedback on this product. And thank you so much for your time.